this on? Is this working? Yeah, it is. Hi. So I'm Yoav Weiss. I am part of the responsive images community group. I am not going to talk about responsive images at all. I work for Akamai on making both browsers and CDNs faster. And I'm here today to talk about the link element, the way browsers download resources, the connection between the two, and how you can help browsers load resources faster using the magic of the link element. So we've spent a lot of time now talking about links, but the problem is that what we refer to usually as links is not what the link element defines. There's some confusion there when you first potentially introduce someone to the web platform and you show him the link element. They would naturally think that the link defines what we refer to as hyperlinks, and they'd be wrong. But link is really about relationships. The rel attribute that Jeremy talked about is what actually defines what link does. So link defines relationships between the current page and resources and online representation of objects on the web. Link has been part of the HTML spec ever since the very first internet draft. And as part of that spec, it's the hidden and underappreciated little brother of the A tag. Both of them establish a relationship to an external document or an external resource, but A has an immediate action to it. It has a distinguished UI to it. You click on a link and you move to the page that it's pointing at. You click on a hyperlink defined by the A tag. The link element has no such action. And its processing, the way that browsers treat it, differ widely depending on the type of relationship that it defines. The original draft included a bunch of those relationships while stating loud and clear that they are not part of the spec. They are not specified. And most of those relationships are long gone, but if we'll take a look at more recent specs, more recent relationships, we'll see that there are a lot of them, but only few actually apply to the link element and perform, basically have significant processing by the browser. So there are style sheets, the style sheet relations for defining external CSS resources, alternate for defining RSS representations of the content, icon for icons. And there are also next and prefetch that we'll discuss later. But other types of relationships are not really applicable to link. And they don't necessarily, there are other relationships that don't necessarily have a UI impact. So in practice, the first time most developers encounter link is when they Google the syntax for style sheets, which, if we're honest with ourselves for a second, it would probably be simpler to define as an SRC attribute on the style element. Unfortunately, link as an element was there. Before style, link external style sheets were defined as their own documents that are related to the current document, and the rest is history. And going back on that decision won't be web compatible because, as you may know, external styles, because they're defined as their own documents, if they have relatives URLs in them, these are relative to the URL of the style sheet, not to the URL of the document. So going back to that kind of syntax wouldn't have been web compatible, so it would probably never happen. But the most exciting part about link is the fact that it's a mechanism, beyond the fact that it has different relations. Each one of them does something different, but there is an underlying framework for creating such relations. There are a lot of nifty nuts and bolts that link has that make it very useful to create such new relations. So we'll go over these various mechanisms. The first one is the rel attribute that we discussed, and it's used to define the relationships. And the best part about it is that it is spec-defined as extensible. New specifications can define new rel values. And over the years, the browsers have implemented various, initially browser-specific rel values that eventually were standardized. And we'll talk about some of them in a short while. One curious thing about link is that if we have a link element in the HTML's body, the question if that is a valid HTML content or not depends on what the rel value is. Some rel values are body OK, while others are not. And that was initially introduced for microdata links, which actually don't have a rel value, but have an item prop instead. But it was later extended to support other rel values. And just recently, style sheet was moved from being on the naughty list to being a body OK relation, even though web developers have been inlining style sheets since forever, and it has been working since forever. One recent change related to that is interesting is that Chrome stopped treating in-body links, in-body style sheets as render blocking, which means that the practice of mashing up various components of pages in the backend and having the link style sheet just above the HTML over which it has an impact actually turns into a performance best practice in that scenario, because that style sheet will not block the rest of the HTML, will not block anything that's above it in the HTML. So everything above it will get rendered properly, but it will just impact everything below it. It will just, the download of that style sheet will just delay the rendering of everything related to the component that it downloads. One of the nice things about rel is that it can include more than one relationship, because just like in real life we can have someone who's a colleague and a friend, or we can have multiple relationships between objects in real life. Same goes for the web. Rel's value is a space-separated list of relations, and developers can define multiple ones between documents. And in order for that to make sense, in order for us to be able to manipulate that list from JavaScript without parsing it and reinventing ways to handle that, we have rel list, which is a DOM token list, if you're familiar with that. And as such, it includes various interesting methods, such as add, remove, contains, which enable us to manipulate the various links. It also, a recent addition is that it includes supports, which tells us if a certain token is supported by the rel list, and enables us to feature detect support for various features, which we'll later see why that is interesting. Another mechanism is href. It's fairly simple, not much to say here. except for the fact that it stands for Hypertext Reference, which I never knew until I researched this. But an interesting attribute is media, which you may encounter, and Simon Peters will later talk about when he's talking about source. But that attribute enables the browser to potentially avoid downloading a resource if the media doesn't match, if the resource is not needed for the user's current context and conditions. It includes a media query, and theoretically, the browser could have avoided downloading that resource in that kind of scenario, in that kind of markup. In practice, Opera, back in the Presto days, tried out not downloading these resources, and a lot of content broke because pages were expecting that style to be downloaded and processed anyway. They expected the CSS OM to be there. So what some browsers do nowadays instead is downgrade the priority of such downloads. So these style sheets will still download, will still block the onload event, but won't, basically, they won't block rendering, and they won't contend on bandwidth with actually important resources on the page. The type attribute is another useful conditional that enables us to tell the browser not to download certain types, MIME types, if they are not supported by the browser. So in effect, they're useless for the current session. And unlike media, that is actually web compatible. Avoiding these downloads is actually web compatible. Blink recently changed, so Chrome, the rendering engine behind Chrome, used to download these resources and recently changed to not downloading them. Personally, I was afraid of that change. I was afraid that it would break content, but the person who did that did their research, and everything turned out fine. The sky didn't fall, and currently, that is something that is a resource that's not downloaded. Still downloaded in WebKit, though, last time I looked. But another interesting mechanism is the onload and on-error events, which enable us to keep track of when resources were downloaded or failed to do so and act upon it using JavaScript. Cross-origin attribute tells us what the core state of the resource fetch would be. I'm not going to go into course beyond saying that it's a security mechanism that enables us to download resources across domains in a safe manner. Some fetches are course-enabled, some are not. And course-enabled fetches are usually fonts. Or in most common cases, it's fonts. Not going to go into course more than that because that could fill a talk on its own. And other interesting attributes that are there. We have a refer policy in order to determine if the refer will be sent or not. We have sizes, which is only applicable to icons and determine their size, not to be confused with the sizes attribute on source and image, which Simon will talk about later, and title and hreflang are not very interesting. And the last mechanism that I'll talk about related to link is the fact that it can be represented as an HTTP header rather than an HTML tag. You may wonder why this is useful, but in some scenarios where you want to automate adding various relations between a certain page and some resources, that can be extremely useful, and it can help you do that without parsing the HTML on the server side. And it can also be used to add such relations between, basically without delivering HTML. It can be relations between other resources other than HTML. But enough about Link. We still have a bunch of time, so let's talk about why loading resources is a complex process. Downloading a full web page is not easy because each web page is composed of tens or even hundreds of different resources, which some of them are loading other resources, and in general, figuring all these resources out is a complex problem, and doing that within a reasonable time frame is even more complex. So just in order to illustrate why this is such a difficult issue, I'm going to tell you a story. So once upon a time, in a land far, far away, browsers were downloading web pages. It's not a very good story. So users used to click on a link, typed in a URL, and then the browser would fetch the HTML data as bytes over the wire, process it, tokenize it, parse it, and construct a DOM tree from it. And then each DOM node would decide which resources it may need. An HTML image element would decide that it needs to download the image resource. Styles, scripts would then see which resource is needed in order for them to be processed and download it. The process was working, but there was one glaring problem with it. Scripts, synchronous scripts, which at the time was the only kind of script, they can have potentially all kinds of interactions with the DOM tree and with the styles applied to the DOM tree. They can modify the DOM tree, they can return different results depending on which nodes are there or not. They can return different results depending on which styles are applied or not. And all that means is that in order to assure correctness, once a script is encountered in HTML, DOM creation has to literally stop. As you can see here, whenever scripts are encountered, we have to wait for the script to finish downloading and then run. But the script cannot run before all styles that preceded it finished downloading and were applied, because it may change, the correctness of the page may change based on the styles that were applied to the DOM. So we basically have to wait for all CSS to finish downloading and then wait for this particular entire file to finish downloading, then we can run it, and then we can continue. And that meant that in practice, waterfalls, network waterfalls, look like this. Once a script is encountered, nothing is downloaded over the network until that script is run, and that script cannot run until all previous CSS has finished downloading. In short, it was really, really slow. So browsers tackled that in that faraway land, which was 2008. They tackled that by decoupling resource download from DOM node creation. They would start downloading resources earlier, while at the same time holding the DOM creation. So they basically decoupled the resource download from DOM creation by speculatively downloading resources. So when an image was encountered, they assumed that in most cases, synchronous script won't override the DOM in weird ways and make that image irrelevant, and downloaded it optimistically thinking that it would be needed. And in most cases, that's actually what happens. So in and of itself, that was a huge improvement. And Steve Souders the godfather of web performance, if you know him, once called it the greatest performance improvement of all times. And this particular mechanism is called different names in different engines. It's called the speculative parser in Firefox, the look-ahead scanner in IE and Edge, the preload scanner in Blink and WebKit. I like to refer to it as the preloader as a vendor-neutral term. And it's important to emphasize that this is not spec'd in any way, and different browsers do different things. What I'm about to describe is the way that it works in Blink and WebKit. Other browsers are somewhat different in their handling. But I'd like to go over the way that this preloader, how does it work? How does it speculatively download resources? Well, the first thing that the browser does is download the HTML file as bits on the wire. That means that these bits don't yet have a char set. Then the browser converts them into the appropriate char set. And the next phase is tokenization, turning them into tokens. But let's talk about this particular HTML for a minute. Can anyone spot a problem there? What is it? Shout. Yes, so the image tag is self-closing. There is no end tag for an image, and div cannot be inside an image. But the tokenizer doesn't know about that, and even if it did, it just wouldn't care. The tokenizer takes these bits of HTML and breaks them off into computer objects that represent each part of the HTML. So we have a star tag for the image with the attributes, a star tag for the div, a text, end tags for both, end tag for the div and end tag for an image, even if there shouldn't be one. The way that it's handled, how does the way that the end tag for the image gets dropped in the parsing phase. The browser constructs a DOM tree from the different tokens, and it encounters the star tag for the image element, creates an HTML image element, and then encounters a div. But before it encounters the div, before it processes the div star tag token, it closes the HTML image element, and the div is a sibling of the HTML image element, not its child. So the preloader basically performs heuristic download in the tokenization phase. It takes the HTML tokens before the tree is created and processes them in order to figure out what is likely to download the resource, and then starts that resource download. And that works really, really well for avoiding that horrific waterfall network download. But it's not resolving the whole problem of resource discovery on the web. It doesn't solve everything. Because basically, web pages today are complex beasts. This is a whiteboard drawing that I drew in a moment of madness trying to figure out the full dependency tree of a certain website. And it's important to emphasize that the browser is only aware of this layer. This is the stuff that's part of the HTML. And everything else is downloaded either as CSS-based resources or as JavaScript-based resources. And this particular tree was 7 layers deep. So the browser has to download a resource and then discover another resource, which then discovers another resource, and you get the picture. So we have a discoverability problem on the web with the way that we build websites and the way that we include third parties, which then download other third parties. What can we do to help the browser? What can we do to make that process faster? How can we help? So there's a recent, before that, the simplistic approach would be to flatten out our dependency trees, to basically stop loading things through JavaScript or load less things through JavaScript and put them in the HTML where they are discoverable. But that's, as I said, simplistic. That's not always feasible. We have a lot of third parties going on. We have a lot of resources that are coming from various places, or sometimes their loading depends on things that are JavaScript dependent. So we cannot always do that. For the cases where we cannot flatten out our dependency tree, there's a new set of standards that was recently added to help tell the browser about those undiscoverable resources and make sure that the browser is aware ahead of time of these resources and can start downloading them faster. These standards are reincarnation of older de facto proprietary tags that were added by pretty much all browsers at the same time. But they were never standardized, and recently they were so. The first one of these, of this bunch of standards is DNS Prefetch, which is a link relation that tells the page that a certain host would be needed in order to fetch resources from, and basically tells the browser you're going to need to go to that host, start resolving the DNS now. If you are aware of a certain host that will be needed, adding this is a no-brainer because the cost is very minimal. On the other hand, the benefits are not huge because we're saving one DNS lookup. We're taking one DNS lookup away from the critical path, not much more than that. The natural evolution of that is pre-connect, which tells the browser pretty much the same thing, but tells it to perform full TCP and TLS, if needed, connection to that host. That's saving way more RTTs and getting them off the critical path, saving a lot of time. The main downside of this versus DNS Prefetch is that you have to know the protocol and you have to know the cross-origin mode of these fetches. The reason for that, the reason that pre-connect has to know the cross-origin mode, the CORS mode of these fetches, which again, basically, the question is whether or not you're downloading fonts from this third-party hosts. And the reason this is needed is because browsers use different connection pools for CORS-enabled fetches versus non-CORS fetches for privacy reasons. And effectively, you have to know what the reason for which you're connecting and tell it to the browser ahead of time. Other rels that we discussed is prefetch, which tells the browser that a certain resource will be needed for the next navigation. So the browser can start downloading that certain resource with low priority in a way that doesn't contend on bandwidth and doesn't interfere with the current navigation, but can still be downloaded in time for the next one. And one other cool thing about Prefetch is that if the user navigates away while the resource is downloading, the download just keeps rolling because halting it there would be silly because it's needed for the next navigation. Other are Linkrel Next, which has been in the spec for a while, and Linkrel Prerender, which is a new addition. They are very similar semantically, and we talked about the rel next as the next page relations. And it's the main thing when this relation is defined as a link is that you can the browser can start pre-rendering that next page ahead of time. If you're certain that a certain page is the next one, we can just start downloading it ahead of time in a background tab. And pre-render is slightly more explicit about that relation. It tells the browser this page needs to be pre-rendered. That's a very high gain, high risk kind of optimization, because if you get it wrong, the user is downloading a full page, including CSS, scripts, and images, all for nothing. But if you get it right, the browsing to the next page is instantaneous. And recently, the AMP project, how many of you are familiar with the AMP project? Okay, so it's a project for accelerated mobile pages. It's a Google initiative. It's Userland, JavaScript framework project that's destined at downloading fast pages for mobile that are slightly, they are restricted, but hence faster. And they actually implemented their own pre-rendering strategy, which just downloads the resources required for the initial viewport view. So they're not downloading any images that are below the fold. They're not downloading anything that's not required for that initial rendering, making their pre-rendering significantly more mobile adapt, because current mobile browsers just ignore pre-render directives because they are scared of the CPU and bandwidth costs. So that could be a nice idea to change browser behavior to, and make sure that the AMP project doesn't have to implement their own pre-rendering and browsers do the right thing on mobile. But my personal favorite, don't tell the other rels, but my personal favorite is the Preload Relation, which is, again, a new addition, and this is where things get serious, because Preload enables devs to tell the browser about a specific resource that would be needed for current navigation. And more than that, it enables developers to tell the browser what these resources are. And it can do that using the as attribute. That's one of the biggest differentiators between Preload and previous attempts at doing the same thing, if you're, in any case, familiar with the sub-resource relation that was a Chrome proprietary thing and is now officially dead. And the as attribute enables the browser to do various things depending on what that resource is. It, first and foremost, it impacts the download priority. So if you're downloading a style, that has higher priority than if you're downloading an image. And downloaded resources can basically fit in the same priority queue as preloaded resources can fit in the same priority queue as regularly discovered resources. The second thing is that it impacts the accept headers that the browser is sending out, which means that you can perform content negotiation on these preloaded resources. For example, you can if we're talking about Chrome, you can serve WebP images because the accept headers explicitly say that the browser accepts WebP, whereas if the browser didn't know what that resource is, it wouldn't be able to send the right accept headers and would just say, I accept anything. The third is that the browser can apply the right content security policy to that fetch and make sure that preloading that resource doesn't break anything security-wise. And it can also perform proper resource matching, which is an internal thing, but it basically makes sure that makes it significantly easier to make sure that internally we're not breaking anything security-wise when downloading this resource. And the thing about Preload is that it enables a whole bunch of interesting use cases for resource downloading. So we kind of talked about the loading of late discovered resources. That's fairly simple. We can just tell the browser, please preload script.js, and this is a script. And the browser can then start downloading that resource with the right priority. A subset of that, which is particularly interesting, is early font loading, because fonts, web fonts, are inherently slow according to the spec. Because the browser has to download the CSS in order to figure out what the URL of the font is, then it has to construct the DOM. It has to find a DOM node that contains text, and that this text uses this particular font, and in some cases that this text also contains a Unicode character that is included in this particular font, and only then it can start downloading a certain web font. So that's a very long process, and that's the reason why we, in many cases, find ourselves browsing to pages that are mostly blank space where the actual text is supposed to go. Now, browsers have implemented timeouts. They have implemented various different strategies in order to make that experience less awful. But inherently, the full download of fonts is slow because it was conceived as something that developers would add to the CSS but won't necessarily be applied to all pages, which often happens. But we can now tell the browser of a certain font that would certainly be needed. If we are certain that a certain font is used on that page, we can tell that to the browser. We can tell the browser, please preload font.wav2, download that as a font. As we said, font fetches are always cross-origin. They're always enabled, not always cross-origin, but always with course mode enabled. So the cross-origin attribute has to be there, even for same origin fetches. I'm sorry about that. I tried to fix that, but that didn't work out. And we can also tell the browser that this font's type is WAF2. That way, if we'll theoretically have a browser that supports preload but doesn't support WAF2 rendering, it will avoid downloading this resource because it's not useful to it. And for that particular browser, it will just download the font whenever it actually discovers it and the text nodes that use it. So this is a very interesting use case for font loading, and a lot of people are excited about that. Another interesting use case enables us to decouple script loading from script execution. which theoretically was also feasible earlier also feasible without preload by downloading the script text using XHR and then evaling it, but that doesn't always work. It breaks in various scenarios. And preload enables us to do that natively without using hacks. You simply declare a link preload, add it to the document, which then triggers the download of the script. And whenever you want to run the script, you just add a script element that then uses the same resource, which matches internally. Whereas if you would download the same script with XHR, that wouldn't have worked. That wouldn't match internally, and the browser would just download basically double download the same resource. Another nifty hack that is enabled by the courtesy of the onload element, onload attribute, is the preload and then basically asynchronous loading based on markup rather than complex script loaders. So we can, that's a hack by, hack would cut it. A hack by Scott Gell from the Filament Group, who uses that in order to basically load non-important CSS without having that CSS block the page's rendering. So you have you just declare a style, you declare a preload, download it as a style. This is the href, and then once the resource has loaded, switch the rel from preload to style sheet, which immediately applies that style to the current page. But before that, the current page wasn't blocking on that style. So if we have styles that are only applicable outside of the initial viewport, that could be a great way to apply them to download them without having them block the overall rendering of the initial viewport. And again, there are solutions to do that with JavaScript, but they're fairly complex, and they're significantly more verbose than this. Another use case is responsive loading, where you can tell the browser to only download a certain resource if a certain media query matches, which kind of links us to what Simon will be talking about later. And the last nice thing about preload is that, like we said, links can be represented as headers. So that enables us to actually automate away a lot of this and add preload relations in an automatic way without having to parse the HTML and inject tags into it, which is also possible, but this makes it way simpler. So we can have automatic engines that detect what resources will be needed for the current page and help the browser discover that earlier using link headers. Now, not all browsers support preload, far from it. It's currently supported in Chrome, and I'm currently working on adding that support to WebKit, which will hopefully eventually be added to Safari. But a lot of browsers don't support it, and some of the use cases actually rely on preload to be supported in order to load certain resources, like the async loading use case. So basically, developers can use the supports method over rel list to see if preload is supported or not. And if it's not supported, perform some other logic that loads these resources as needed. How many of you are familiar with HTTP2 Push? Some, but not a lot. So basically, HTTP2 includes a feature, HTTP2, the new version of the HTTP protocol, includes a feature that enables the server to push resources to the user. It's a great feature, and a lot of people find that that feature is somehow conflicts or oversteps what Preload does. But in many ways, these features are complementary. H2 Push enables the server to start pushing resources way before the HTML has hit the browser. So it can start filling up the bandwidth way earlier with critical resources. But at the same time, there's a lot that H2 Push cannot do and that Preload can. So for example, Preload can tell the browser to preload cross-origin resources. It can take into account cache and cookies. It has load and error events that enable us to build various application-related logic based on these preloaded resources. It enables us to perform content negotiation, so going back to the WebP example. And one last thing related to rel, which is something to look out for, which also emphasizes why the link header is so important. There is current work about adding a rel service worker. How many of you are familiar with service workers? Cool. So yeah, better. So service workers are awesome. They enable us a lot of things. They were designed for offline, but enable us a lot of things beyond just offline support. And there is work underway to add a rel service worker, both in tag and header form, that enable both the HTML and other third-party resources to define link relations. So for example, Google Fonts will be able to define a rel between its CSS and a service worker that's applicable to that CSS. So that's work that's underway. It's not currently supported anywhere, but it is exciting. Main takeaways here is that links are cool, but link as a mechanism is even cooler. And we can use that in order to build cool web platform features related to resource loading. Resource loading is a hard problem for browsers. You can make it easier by flattening out your dependency trees, but in cases that is not possible, you can use preconnect and preload in order to tell the browser what's about to happen and help him help you. Thank you.